Question 34. A university uses gas to heat its buildings. Over a period of 10 weekdays during winter, the gas used each day was measured in megawatts and the average outside temperature each day was recorded in degrees Celsius. Using X as the average daily outside temperature and Y as the total daily gas usage, the equation of the least squares regression line was found. The equation of the regression line predicts that when the temperature is 0 degrees Celsius, the daily gas usage is 236 megawatts. The 10 temperatures measured were 0 degrees, 0 degrees, 0 degrees, 2 degrees, 5 degrees, 7 degrees, 8 degrees, 9 degrees, 9 degrees and 10 degrees. The total gas usage for the 10 weekdays was 1,840 megawatts. In any bivariate dataset, the least squares regression line passes through the point x bar, y bar, where x bar is the sample mean of the x values and y bar is the sample mean of the y values. Part A. Using the information provided, plot the point x bar, y bar and the y-intercept of the least squares regression line on the grid. The first thing I found was the value of x bar, which represents the average of the 10 temperatures recorded. Now here are the 10 temperatures recorded. Either use the stat mode on your calculator or just add the 10 values together and divide by the number of values, which is 10. So adding these values together, we get 50. Dividing 50 by 10, we get 5. So x bar is equal to 5. Next, find the value of y bar. Now, y bar represents the average of the gas usage over the 10 weekdays. And the clue to work that out is found in this line here. So the total gas usage, in other words, the sum of the scores, is 1,840 over the 10 weekdays. And there were 10 measurements that were taken. We don't know the individual measurements. What we do know though is the sum of those measurements. So taking the sum of the scores and dividing it again by the number of scores, which is 10, y bar is equal to 1,840 divided by 10, which gives us 184. The final step is to find the y-intercept. And the clue is given in this sentence here. So the equation of the regression line predicts that when the temperature is 0 degrees Celsius, in other words, that's a value that's on the y-axis, the daily gas usage is 236 megawatts. So we can read this directly as the y-intercept, and I've noted that here. So the y-intercept is 236. Now we can take this information and plot those points on the grid. So I plotted the y-intercept here, just taking note that every square vertically represents 2 megawatts. So there are 5 divisions there from 230 to 240, so 236 is just there. And the point x bar, y bar is this point here. Part B. What is the equation of the regression line? To work out the equation of the least squares regression line, we need 2 bits of information. We need the gradient of the line. We also need the y-intercept. Now the y-intercept is already given, so we don't need to work that out. We just need to make sure that that's incorporated in our final answer. Now to work out the gradient of the line, there's one of 2 methods. Either we can just draw a triangle, work out the rise, work out the run, and gradient equals rise over run, noting that it's a downhill or a downward sloping line, so the gradient will be negative, or we can use the 2-point gradient formula. In my solution, I'm going to use the 2-point gradient formula. And this is the point x1, y1, this is the point x2, y2. So using the 2-point formula, the gradient m is equal to y2 minus y1 in brackets, so that represents the rise, divided by x2 minus x1, which represents the run. And substituting the respective values for y2, y1, x2, x1, we get gradient m is equal to 184 minus 236 in brackets, divided by 5 minus 0. And that evaluates to negative 10.4. So putting that all together, now that we know the gradient and we know the y-intercept, putting it in the form y equals mx plus c, the equation of the regression line is y equals negative 10.4x plus 236. Part C. In the context of the dataset, identify one problem with using the regression line to predict gas usage when the average outside temperature is 23 degrees Celsius. The question is asking us to identify one problem or issue using the regression line to predict gas usage. In this sample solution, I've given two problems or two issues that I've identified. There may be others, but I'm going to go through these two issues one at a time. Firstly, when x equals 23, using the equation of the regression line that we found in part B, we find that the y value, which represents gas usage, is negative 3.2. And that's a nonsense answer. It's invalid since gas usage cannot be negative. It cannot be less than 0. The other reason is that extrapolation beyond the range of data is unreliable, as it cannot be assumed that the model remains linear outside the range of values given.